After completing the entire course, probably would like to do some problems based on the structure and the symmetry that we have studied in the entire course. I suppose you are ready. Let's begin. Again, I'm Saurabh. And we'll be talking about the exercises. The solutions of the exercises will be not given in this video. It will be provided separately. However, let's get familiar with the questions that come to your perusal. Number one. The phosphorus oxytrichloride molecule belongs to the point group C3b. Now the point group is given. List all the symmetry elements of this point group and locate them in the molecule. You are familiar with ammonia molecule? Do accordingly. Question 2. Carbon tetrachloride molecules of course belongs to TD symmetry. Find out the symmetry elements in operations. You can do it. Just observe any video. There in many videos the operations regarding TD point group have been explained. The next question talks about the polarity of the molecule. You have to decide for pyridine C2b symmetry, nitroethane, and gas phase HGBr to the infinity H, and the inorganic benzene kind of molecule which have a D3H symmetry. Predict the basis of symmetric considerations for these molecules, and are they polar? Well, yes, in one of the videos that we have described the criterion for a molecule to being polar. Go through that and solve this. Again, the same kind of question, more examples like CH2Cl, C3b symmetry, W2CO10 that belongs to a D4H symmetry, then SnCl4, that is tetrahedral symmetry. The same kind of question has been repeated, but then you understand how and where you can consider the polarity of the molecule. This is important. Use the symmetry properties to determine whether or not the integral Px(z)Pz is necessarily 0 in a molecule with symmetry D6H. You please go through one of the video that explains how we can describe about the integral that is necessarily 0 or non-zero. It's quite not difficult to work out. Simply go through the character table for D6H. If we are talking about A1 and A2 transition, show that the transition A1 A2 is forbidden for each electric dipole transition in a C3b molecule. Again, refer to the same video. Similarly, the transition A1G and A2U are forbidden for electric dipole transition in a D6 molecule. Is just so? Again, refer to the character table and get the inference draw. Show that the function xy has the same symmetry species as B2 in the point group C4b. Nothing doing, simply go and watch the character table for the C4b point group. Show that the function xyz has the same symmetry species as A1 in the point group D2. The same thing, go to point group D2, draw the character table, refer to the function xyz and see if it belongs to A1. Then molecules belonging to the point group D2H or C3H cannot be chiral. Which element of these groups rule out chirality? Think of it. Quite easy to analyze. Molecules belonging to the point group TH or TD cannot be chiral. Which element of these groups rule out chirality? Interesting? Yes, go and find out the reason. The group D2 consists of the elements identity C2, C2 prime, C12 prime, where the 3 to 4 rotationals are around mutually perpendicular axes. Construct the group multiplication table for this. If you want to do it, you just refer to a similar kind of group multiplication table like C2H and you will be able to do it. The group C4b consists of these elements. Construct the group multiplication table. I suppose in the list of videos you'll find one of the video which has a group multiplication table for C4b point group that you have to see where it is and then work accordingly. Again, we have to identify the point groups for certain geometrical objects like a sphere, isosceles triangles, equilateral triangle, an upper cylindrical pencil, and a square. Very easy to see the result. Please go and help yourself. Identify the point group to which the following molecule belongs. A sharpened cylindrical pencil we have seen now. Now it has changed here. A 3-bladed propeller, a 4-leg table, and you can also approximately try about yourself. Had your face been not there, what would you have? Your own symmetry. Interesting? Yes. List the symmetry elements of the following molecules and name the point groups to which they belong. NO2 and 2. CH3 chloroform, CH2 CH2, cis and trans dichloro or dibromo derivatives of ethene. Again, very simple. You'll find the solutions in some of the videos, I'm sure. List the symmetry elements of the following molecules and the point group to which they belong. Naphthalene, anthracene, and the 3 dichlorobenzenes. Well, very easy. Naphthalene and anthracene, I suppose you will find in certain videos inside. And the dichlorobenzene derivatives have also been given earlier, but again, there were also, we have not given the results in that sequence as well. Try to work out for yourself. It's quite easy to understand. Assign the following molecules to the point groups: HF, IF7, XeO2F2 seesaw structure, iron carbonyl, cubane C8H8, tetrafluorocubane C8H4F4. Not very difficult to assign, only just look at the structure and compare with the other elements. In one of the videos of molecular point group, we have described some of the structures. Which of the following molecule can be polar, like in the same questions that have been described? And now consider the case of C2B molecule. That's the example of NO2. The combination of PXA species to PXB species of the two oxygen atoms with X perpendicular to the plane trans A2. Is there any orbital of the central atom N that can have a non-zero overlap with the combination of O orbitals? What would be the case in SO2 where 3D orbitals might be available? That is a very interesting thing. Go ahead and find it for yourself. The same is the case with nitrate ion, that is a D3H typical planar structure, 2pZa, 2pZb, and 2pZc. Or what would be the case in SO2 where the 3 orbitals might also be involved? Now you can see, examine yourself. The ground state of NO2 is A1 in the group C2e. To what excited state may it be excited by electric dipole transitions, and what polarization of light is it necessary to use? You have to see the electric dipole transitions and act accordingly. Cl2 molecule belonging to point group C2e was trapped in a solid. The ground state is known to be B1. Light polarized parallel to the y-axis excited the molecule to an upper state. What is the symmetry of that state? What states of benzene and naphthalene may be reached by electric dipole transitions from their totally symmetric ground state? That we have worked out the molecular orbitals for benzene and naphthalene. Probably you will be able to look and conclude. And the same is with the anthracene and chlorine. Function F1 equal to sine theta and F2 is equal to cos theta. Show by symmetry arguments using the group CS that the integral of the product over a symmetry range around theta is equal to 0 is 0. So that means it's a 0 integral that you have to see. Quite easy, a bit of mathematics. Determine whether the integral over F1 and F2 in an exercise 27 is 0 over a symmetrical range of theta equal to 0 in the group C3b. Now we have to change this time about C3b point group. Consider the character table for C3b. Yes, this is a Kekulé molecule, that is a very superannuline molecule, and the structure of this molecule has been established quite recently. What would be the point group of this molecule? Just think it and write your answers. That's all for now. We'll be adding more and many more questions in coming videos, but this is okay for now. Thank you for watching. Thanks again.